Assalamualaikum, nama saya dan nombor induk saya adalah 07DK20F2057. Hari ini saya akan menerangkan tentang tas 1 dan tas 2. Saya akan menerangkan tas 1 terlebih dahulu, di mana dia meminta untuk identify the catchment area and data required. Untuk tugasan kali ini, kami diminta untuk mencari catchment area untuk Sungai Rendet, dan rainfall station yang berdekatan adalah Gunung Bincang in Cameron Highland. Terdapat 10 stesen yang digunakan untuk mini project ini. Input data pula dikira bermula pada 21 Disember 2021 jam 12.30 malam dan berakhir pada hari yang sama jam 12.30 hari. Seterusnya kita diminta untuk mengira precipitation area yang telah diberi, dan kita hanya perlu meng-key-in data dalam HMS. Seterusnya kita diminta untuk mencari characteristic Fringlet catchment, di mana dia meminta untuk mencari length of subbridge, TC, R, dan juga initial discharge. Dan jumlah untuk length of subbridge adalah 6.216.71. Tas kedua pula adalah create basic model by adding and connecting hydraulic element, which is 25-year ARI and 50-year ARI. Dan saya akan menunjukkan langkah di mana kita menggunakan HMS.
First thing first adalah create new file untuk HMS, iaitu name mini project dan description pula adalah hidrology. Setelah itu save kepada mana-mana di scope yang anda ingin letak. Setelah itu, pergi komponen dan create basin model dan letak nama untuk new adalah 25-year ARI, dan seterusnya tambah satu lagi untuk 50-year ARI. Setelah itu, tekan komponen untuk create new methodology model. Sama seperti basin model, rename untuk 25-year ARI, description juga 25-year ARI. Setelah itu, tambah methodological model untuk 25-year ARI. Setelah itu, pergi ke komponen dan create lagi untuk control specification untuk 25-year ARI dan juga 50-year ARI. Setelah itu, create time series data untuk mini project hydrology ini. Setelah itu, tekan basin model, iaitu yang pertama iaitu 25-year ARI, dan kita akan create a sub basin untuk basin model, iaitu C1 sehinggalah C10. Seterusnya kita akan create junction untuk C1 sehingga C10 bagi 25 year ARI.
Dan begitu juga untuk 50-year ARI. Setelah itu sambungkan junction kepada junction yang bersebelahan untuk konekkan setiap junction. And now kita akan isi setiap data untuk basin model dan juga junction bagi 25-year ARI dan juga 50-year ARI.
For task 3, we have got to methodology models and control specification. In methodology models for 25 ARI, we go to basin and change the 25 ARI to yes, and we go to 50 years ARI, change to yes. Next, we go to control specification. We go to which is 20 years ARI. We fill this specification, which is start data 21 December 2021, start time 00.00, and date 21 December 2021, and time 12, and same step for 50 ARI, then save. And this one, we wanted time series data, which is for mini project, and this one we change to same started and the end of the data like this. And this specification will be added to the table if you want after we add the data, and we can get graph for publication like this, graph for time series.
My name is Siti Nofaiza binti Yusuf. My matrix number is 07DKE20F2083. Now I will explain about task 3.
And the last step is for task 4. We have go to compute and add simulation run. For run 1 is next 25 ARI, next 25 ARI, next and finish. And we go to another one for 50 ARI, finish. So we have run 1 and run 2. And the last step is go to compute and just step run and click here and we done. And same step for run 2. So from here ratio we get the result.
Hi, my name is Efana Jihab binti Abdul Razak, number matrix 07DKE20F2005. So, I will continue my task 5, which is graph and summary table. First, we're going to the graph and summary table in 25-year ARI. As you can see, this is some of the graph for 25-year ARI, which is C1. So, upside of the graph, we have depth in millimeter, while downside, we have flow in centimeter per second. Next is summary for data 25-year ARI. It has the highest volume of rainfall, which is C6, 174.1 meter cubic, and the lowest volume rainfall are C2 and C10, which is 90.0 meter cubic. Next, we're going to the graph and summary for table and 50-year ARI, where the upside of the graph we also have depth in millimeter and downside we have flow in centimeter per second. Then the summary data for 50-year ARI, we also have the same highest volume of rainfall, which is C6, 174.1 meter cubic, and the lowest are C2 and C10, which is 90 meter cubic. So it can be concluded that location and the impact on the amount of rainfall received but not on peak immersion. That's all. Thank you.
So hello, good morning. My name is Maxine Fabian. My registration number is 07DKA20F2091. So now I'm going to explain the use of hydrograph, where hydrograph is a graphical representation the flow rate of discharge of water in a river or stream over a period of time. Hydrographs are essentially tools in hydrology, the study of water in the Earth's atmosphere, on the land surface and underground. They provide valuable information about the behavior and characteristic of water in a particular watershed or catchment area. Next, why hydrographs are important in the field of hydrology. First, flood prediction and management, where the hydrograph provides vital information for predicting and managing floods. By analyzing the shape, magnitude, and timing of hydrographs, hydrologists can set the potential risk of flood and issue time warning. Second is for design of hydraulic structure. By analyzing hydrograph, engineer can determine the storage capacity, spillway design, and flood routine characteristic of this structure. This ensures the safety, efficiency, operation, and preventing potential disaster. Last, I'm going to explain the impact of climate change on hydrograph. First, altered stream flow pattern. Climate change can lead to change in precipitation patterns such as increased intensity of rainfall events or shift in the time and distribution of rainfall. This change directly affect the hydrological cycle and result in alternate stream flow pattern. Hydrograph may exhibit shift in peak flow, change in the timing of high and low flow, and modification in the overall volume and duration of stream flow. Second is change in base flow. Base flow refers to the portion of stream flow that comes from groundwater and sustained stream flow between precipitation events. Climate change can affect base flow by altering groundwater recharge rates. Change in temperature and precipitation pattern can influence soil moisture level and groundwater availability, ultimately impacting the base flow component by hydrograph. Thank you.